Oh, okay, so let's share the screen. All right, so we're sharing now. Let's start the VM. And we're going to start with problem number 2, which should help you to do problem 3. All right, so we have our computer. Log in. Now, CD with the desktop. Let's go into fall 2025. I'm just going to create a new folder. I'm going to call it digital signature. So performance, digital signature and performance. All right. Yeah, so let's try this one. Let's first create the file. So we're going to create a file called example.txt. And we're going to write in here, hello, this is Bob and us. Okay, so just some text. Control X, enter. Okay. Now we look at ls-l. We have our example.txt. Then we're going to, as you know, we're using RSA for digital signatures. So this involves a public and a private key pair. So we're going to go ahead. I think we did some of this on Tuesday, right? So we were using openssl to create public and private keys, if you remember. Gonna try to do this again. I'm gonna do openssl gen RSA dash pass out. Give it a password. Pass just for additional security. 13579. Okay. I'm gonna hit space. Then I'm going to do dash out Oops, dash out. And we're going to generate the private dot m 1024. It's the size. Okay. All right. So that gives us the key. So now we can take a look at it. If we do ls-l, we have our private.pem. So I'm going to do cat private.pem. And you guys can see that this is in fact private key. On Tuesday, I showed you how to get everything from this one, right? So don't forget how to do that, although we don't need that today. All right, so now we're gonna get also, as you know, we're missing the public key. So we need to have that also. So we're gonna do open SSL RSA dash pass in pass 13579 dash pub out dash in private dot hem dash out public dot hem. Okay. All right. So hopefully that worked. And you can see we now have a private and a public key. You can always check that the size is much smaller. Public hem, and there we are. And if we wanted the parameters, we know how to get them now. Okay, now we need to perform the signature. This is going to be very straightforward. As I said, in the problem, you need to simulate this time around. And in a couple of weeks, you will actually do the actual certificate authority. But it's a very involved process, believe me, right? To do it in Linux properly. So for now, you're just going to simulate the idea, which, and that means you would create a set of public and private keys, and I would just call them CA public, CA private. And that way, they provide, that's what they are. All right. So now let's go ahead and sign example.txt. Okay. So I'm going to do open SSL DGST digest dash SHA 256. If you remember from the logic in Python, SHA-250, we always use for signatures, integrity and authentication together. Okay, so OpenSSL DGST dash SHA-256 dash sign with what in this case with a private key, private.pem. Okay. And then that generates dash out example dot SHA 256 and example, and then with example dot txt. Okay, so we provide that we're signing, we provide the private key, we want the output, the signature to be example SHA-256, and we also need to provide example.txt, the actual document that we're signing. Okay, no errors, so that's good. Let's do ls-l. You can see now we have example SHA-256. We can cat that one. And you can see it's an encrypted file. I'm going to hit clear here. All right. So now let's do ls-l. we can see we've got our signature, we've got our public and private, and we've got example.txt. Now we can proceed to verify the signature, right? So that's essentially what we do. We verify the signature. So how do we do that? Open SSL, DGST dash SHA 256 dash verify public.pem dash. So here we are. We're using still SHA 256, but now instead of signing, we're verifying. What key do we use? The public key. Okay. Dash signature, which should be example dot SHA 256. And then we provide example dot txt, the original message. If I hit enter, verified, okay. Do you guys see that? That's it. If you remember with signatures, you just get okay or false. So if I asked you the question, what pillars did we achieve with this operation? And I gave you like true or multiple choice, right? So I gave you like authentication, integrity, confidentiality, or integrity and authentication. Which one would you say? Integrity. Yes. Why not confidentiality? No. In this transaction, when you sent example.txt, did you send it in plain text or encrypted? In plain text. Do you see that? So I can read it. That's how you should go about it is, can I read this? Yes. So it's, there's no confidentiality involved, but there was integrity and authentication. Now, for the question I'm asking on the PyCrypto lab, remember I'm saying in one shot achieve confidentiality, integrity, and authentication. And what I mean is this, that if you send example.txt in plain text like that, you did not achieve confidentiality. Do you guys understand now? So what do you have to do? You have to take example.txt first, encrypt it, and then sign or hash that cipher, and then calculate the signature over that hash of the encrypted thing so that you can send it. Or there's other ways of doing it, but that's one way. Do you guys understand? Okay. So yeah, that's problem 2, I think. And I'll leave the second part to you, which you have to corrupt a bit and then verify, right? So let's read through the problem again. So it says, create a digital signature. In this task, we will use openssl to generate digital signatures. Please prepare a file example.txt of any size. Please also prepare an RSA public and private key pair. You know how to do that. Then do the following, sign the SHA-256 of example.txt, save the output as this file, verify it. We've done all that. Now what you need to do is slightly modify example.txt and repeat the verification of the digital signature. Any questions on that? So I'll leave that for you guys to solve. And so that's problem 2. Now, maybe problem 3 makes a little bit more sense, right? Because you'll be using the exact same process, but you have to now achieve more things. So using any symmetric encryption approach, such as openssl with AES, send a message to your partner and achieve confidentiality. This time you must exchange the symmetric key securely and correctly using RSA. Additionally, add a digital signature to authenticate the required keys. You will need to create a certificate authority as a trusted party for this. So that's what you need to add in there. And remember, so the secret here is that it's fine if you just take the public key, and that public key has the digital signature from the third certificate authority. Any questions on that one? All right, perfect. So it seems like you guys get it. So yeah, so I'll leave that problem to you guys to work with your partner. These are the key things to, to understand. All right, and then now we can focus just on the first problem, which does require a little bit of coding. So we're going to go over a script that I'll provide, and then you guys can play with it just so that you can try to measure performance. So that's really the idea. And then once we finish that, whatever time we have left, work on the assignments or practice the PyCryptodome uh, demo for next week. All right, so let's take a look at problem 3, or problem 1. So this is the performance comparison of RSA versus AES. So let's start with the easy part. It gave us a couple of commands to run, just like the ones that we ran on Tuesday. Let's take a look at those. It simply says to run openssl speed RSA. You can see it's going to run several tests. As you can see, we've talked about how 512, or 124 or 248 are the seeds that determine the size of the prime and the security of the model. So you can see that it ran the different sizes or different size keys that we need to run in RSA. And essentially, it's averaging for an encryption about 9 seconds, right? Do you guys see that? So this is kind of, whenever you're doing this, it's taking 9 seconds to do for the operation that you need to do, right? Do you see? Now if you run AES, it should be openssl feed AES. And this is going to, you can see it's using AES 128 bit, etc., which is what would be fine for encrypting a file, right? Some text to achieve confidentiality. And so this is kind of like whenever you're encrypting, you'd be using these parameters for RSA and you'd be using these parameters for AES. And you can see that the AES is taking on average about 3 seconds. So now imagine if you were using RSA to encrypt that movie, right, from Netflix or whatever it is, it would be taking 3 times as long, right? So it's one way of thinking about it. So AES is definitely faster, and that's why, the big bulk of the work in cryptography is confidentiality, encrypting that very long movie. So we use, something like symmetric encryption, AES, for that. For the key, which also can be a burden, but it's a lot less because it's just a small, remember, for asymmetric encryption, it's just really for key exchange, so RSA. And Diffie-Hellman, I think we did on Tuesday, and we saw that it was even slower. So that gives you a picture of how that it's true, right? That these algorithms, are some are slower than others. All right. And then the last part that I'm going to cover then is just to kind of do like a little experiment, if you will, of how you could, on your own, if you wanted to get more details, how can you measure performance? So this is a short script, shouldn't be too bad. I'm going to use the same keys that I created, the private and public key for RSA. Okay. And we're going to perform some encryptions and decryptions using openssl, RSA, and AES. And it just gives you a way of measuring performance. Okay, so just to stress that point. So I'll give this script, it's not really that. It's a bit long, but not that bad. Okay, this is going to be in Bash, right? So it's just why Bash? Python, might be a bit slower here. Bash is going to run a little bit more efficiently for performance. So let's go ahead and do that. And don't worry if you don't know Bash. When you take 372, you'll cover a little bit of it. So yeah, I'm just consider it for the experiment. All right. So yeah, so we've got the public and the private key there. So I'm going to be reusing those. I'm going to create a script. Be careful with this one because Bash is not very forgiving when it comes to syntax errors. And we may need to use either Bash or Dash for running this. But we have this VM has two shells. But anyway, let's go ahead and try it. So nano, let's give it a name, compare .sh. Okay. So we're going to say that we want to use bin. Sage. Go. This is going to be so we're going to encrypt first. So RSA encrypt. And as I said, the point of this is just to measure time. So we're going to have a variable called start one, and it's going to use these little symbols. I think this is called a tilde or the inverted single quote. It's on the where you have the squiggly line on the upper right corner of your keyboard, right? Yeah. So start one date and then single quote, plus percentage S, and then the tilde again. Oops, this one. Yeah, here we are. Okay, this is just to calculate the exact date at the moment you start, date and time, and then to calculate the date and time when you finish. And that way you can take the difference and it's going to give you the actual speed. So it's like a counter. Okay. Then we're just going to repeat oops, sorry. Go down here. We're going to repeat a for loop for uh, I equals 0, semicolon, space I less than, what is this, 10,000. This is what I said. The encryption is probably too fast to do just one, so just repeat it like 10,000 times. And that way, we're going to be consistent, and so we can compare apples to apples. So we add a semicolon here. So this should be 10. And then I plus plus, close parentheses, close parentheses. Then we're going to do. Then let's do two spaces, 1, 2, open SSL, RSA, utility, dash encrypt, dash pub in, dash in key, public dot m dash in message dot txt dash out message dot message underscore encode dot txt. Okay, we're just running the encryption command. Here, for those of you that haven't taken 372, don't worry about it. For those of you that have taken 372, you should know what this is. 1 greater than /dev / null, and 2 greater than ampersand. Whoop. Although it looks like very cryptic, right? It's a very standard thing in Linux on the command line, redirection, right? To null, essentially to like a black hole. This is just so that the output does not print out to the screen. So we covered this in the redirections. All right. But yeah, just add this. The end. So you're running 1,000 iterations, it would generate output, right? But here we don't care about that output because all we want to do is measure the performance. So just throw it to the dev null unit, which is like throwing it into a black hole, essentially is gone. All right. So I'm just double checking the syntax here. Yeah, so that should be correct. And we're like 33% done. So now let's do done. Okay. And then we calculate finish one. Finish one. And it's going to be the same thing. We use that symbol again. Tilde. Oh, need an equal here. Tilde. We add date, space, single quotes, plus percentage S. Oops. Tilde again. Okay, so that's finish one. And then we calculate the difference. So we're going to say used one equal, again, tilde, echo in double quotes, $, finish one minus $, start one, pipe to BC, and N tilde. Okay, so that will just print out the difference, how long it took from beginning to end, so you can benchmark that process, okay, for the RSA encrypt. Now we repeat the exact same thing, but for RSA decrypt. You see how I'm doing this, and we're just going to print out the results in the end. So the next step is, oh, we need to print this out, obviously. So I'm going to do echo total time is $, used one, and this should be in seconds, just like that. So that should print out the first one. Now we do the next one, which is going to be RSA decrypt. So I'm just going to repeat essentially the code here. So echo RSA decrypt, RSA decrypt. Okay, so start two. We assign to it date, single quote, plus percentage S. Yep, and then we add the for loop here. So for I equals 0, I less than 10,000. We want to do the same. 10,000. I plus plus. Okay. So do open SSL RSA utility dash decrypt dash in key. Now, which key do we use? Private.pem, right? Because we're using decryption. Dash in, oops, dash in message, that same message we just encrypted. So message dot or underscore. encode.txt. And now we just once again redirect. So the same thing. One, redirect to dev null to ampersand. Should be consistent. Okay. And we hit done. And now what do we have to do? We have to compute finish, take the difference, print it out. So the same thing as before. So I'm going to do finish. Did I do start? Yeah, start 2. Now I'm going to do finish 2. I assign to it date, single quote, plus percentage S, and then it ends with a single quote and a tilde. And now I calculate used to, which is the difference. So it's going to be tilde again, echo in double quotes, $, finish to minus $, start to type BC. As a funny joke, while Bash is extremely powerful, it now makes you really appreciate Python, right? So you can see why something like Python has really become the most popular scripting language. Before Python, there was Bash, Perl, what else? Bash, Perl, some other ones, I'm sure. And they're like this. Coding is like this. And spaces and things. Now, it's extremely, if there's one that I do recommend that you do learn is this one. Certainly, I'm not saying it's not important, especially for Linux admin, but you can see why Python is preferable. All right, so um, and you can do this in Python if you'd like, so you can try it. All right, so this is used to echo finish to minus start to BC. Okay, so that's done. So now we just print it out, echo total time, and in this case, $ used 2 seconds. All right, so we're like 66% done now. And all we need to do is add the third one, right? So the third one is going to be pretty much the same thing. We're going to measure how long it takes to process AES. Okay. So just measuring performance. So now we do echo AES. This would be like 128 that we always use. Okay. So we need to set up a third variable, in this case, start 3. Oh, let's do okay. Start 3 tilde. So again, date, single quote, plus percentage S, single quote, tilde. And now we have a for loop for I equal 0, semicolon, I less than, again, 10,000, semicolon, I plus plus. Okay. Do want to open SSL AES dash 128 dash CBC. So you guys should be familiar with this command, right? So going back to the very beginning of the semester, open SSL AES 128 CBC dash K, uppercase K. And let's just give it a key here. So I'm going to say 000 102, and then it's going to be 03, 04, 05, 06. 07, 08, 09. And then let's do A0, B0, C0, D0, E0, E0, F. Just like that. Dash initialization vector. Don't forget that those are needed. Pretty much the same for this one. We don't really care about security here. We're just doing a performance focused lab today. So 09, and then we add 0A. Notice these are actually inverted. Are they? 09. Yeah, 0A. No, they're not. It's the same. Yeah, I just read it incorrectly the first time around. Okay, so it's 0A, 0B, 0C, 0D, 0E, 0F. Okay? Doesn't really matter. But just something of this length, okay? Now, and that dash in, space, dash in, it's going to be message dot txt dash in message dot txt. Then we redirect again. So I'm going to do one redirect dev, redirect null, to redirect ampersand one. And then we hit done. And we're almost finished. Then we have variable finish 3. And this again, tilde, date, space, single quote, plus percentage S. And now we just need to calculate the difference in the variable. Okay, so it's going to be used 3. Okay. Single quote, echo, and we take the difference. So it should be finish 3, right? Minus, and that should be $sign. So $sign. Finish 3 minus $sign start 3. Start 3. Double quote pipe BC. And now all we have to do is print it out, and that's it. So echo total time is $ used 3 seconds. Okay, and that's it. So that's the whole script, just to measure performance, just give you an idea. This may run with SH or bash. We'll have to try it out. So I think it runs with bash. Okay, so it's running. Let's give it a second. So it's doing 10,000 encryptions, right? So that's why it's taking a while. Maybe for my demo, I should have just done like 100. I might do that if yeah, because it's taking a long time. Let me change that. I want to make sure that it runs. So I'm just going to change all of these from 10,000 to 100. Okay, so 100, 100. Do you guys see that? And then, okay, so yeah, so you can see, okay, here we are. So a little bit better. Yeah, so it ran fine. Make sense? So that's what you guys just make sure you run it to 10,000 times to measure the performance of this approach. Any questions on problem number 1? Guys, so we've completed the code for it. Just go ahead and run it. If we go back to the Word doc, it says, everything that we did here is fine. And just talk about it. Any questions? Everyone good? Pardon? Yeah. There you are. All right. So yeah, you can take a picture of it. That's essentially problem 1. We did problem 2. I leave problem 3 to you because you need to practice just using these scripts to be able to answer all the things. Make sure if it's asking for confidentiality, integrity, that you're achieving all of those correctly. You have all the tools at this point. I don't know if you realize, but you know how to do everything at this point. Everything that's left is really applications, like how to do a certificate authority properly in Linux, but you can actually simulate your own right now, right? Because you just have to know which keys you need to use properly. You have all the code in Python and openssl to do everything. What's left is like elliptic curves, but that's just an advanced algorithm for asymmetric encryption. You can just use RSA. Integrating Diffie-Hellman into that, but you already know how to do Diffie-Hellman. So really, we just have that theory, and then yeah, this is actually kind of like, you have everything, all the tools to achieve pretty much all the pillars of cryptography. Okay, and then what's left is more like application side. We will do one more lab on HTTPS and a few other things, obviously, elliptic curves, things like that. But yeah, so just practice these problems, and also I remind you, you have to complete this assignment, and also you have your PyCrypto, right, which I extended the deadline, I believe, but you still need to do the demos a week from today, and the exam is on Tuesday. Any questions for me? All right, I'll end this video here because that's my demo. and I'll just answer questions if you have them related